Give everybody another 30 seconds to join, and then we'll get started. All right. Welcome in, everybody. So this afternoon, we are going to be talking a little bit more about how the web works, and then we're going to get back into APIs a little bit. So how the web works, this should really, a lot of this is going to be like more general information about how the web works, and then we'll get into like how that necessarily relates to APIs. So if you'll remember at the beginning of the mod, we had one class on how the web works and really getting into the key parts that we need to understand for building our Rails apps. And so now we're going to layer on a couple more topics around that, around just like how the web works, that's going to be very relevant for consuming APIs. And especially when you get into mod 3 and start doing more complex things with APIs. So I'm going to start by dropping a warm-up activity into your cohort channel. So I want everybody to open up a notebook or a document on your laptop or something, and go ahead and answer those questions. I'm going to give everybody 5 minutes to do this. So we'll come back together at 1:07 to go over it. Take about 1 more minute, and then we're going to go over this together. All right, so I've made a Google Doc for us to take notes in, and I've also dropped the link in the cohort channel if y'all would like to follow along or need access to it later. So yeah, let's go over this, and I'll take volunteers for these questions. So describe the HTTP request response cycle and use each of the following terms. Yeah, let's go to Alex.
I could be wrong right out of the gate, but the client is the user, I hope, that makes the HTTP request, and it goes to the server. And then magic happens, and then the HTTP request or response is sent back to the user. And I can keep going.
Yeah. So whose job would it be to send back that response?
The server.
Yeah, there you go. That was great. So I say sends back in HTTP response. Yeah, great job, Alex. One clarification I might make is that the user and the client are distinct. So the client is the thing that sends the HTTP request to the server, and the server sends back the HTTP response to the client. But the user is a little bit different, but that's a great starting point. Can I hear from someone else? Let's go to Jen.
So just to clarify, like an example would be like the user would be me and the client could be Google.
Yes, exactly.
Okay.
So I could say the user uses the client. Yeah.
Thank you.
And so something else Jen said in our, I'll say a lot of times, this is a web browser. So when you think client, I really want you to think web browser at this point, especially with all the apps that we've been building. We've been building apps for humans to use. So the human user, so I'll say like usually a human user uses their web browser. Oops. Browser sends the HTTP request to the server. I like what Alex said earlier, magic happens. We don't really care too much at this point about what the server does, but at the end of it, processing the request sends back that HTTP response. Cool. I'd love to hear from some more folks. What can we add to these notes here? What can we describe in a little bit more detail? Richard?
HTTP is the protocol.
Mm-hmm. And this is the protocol for what? Like a protocol is like defining some sort of like rule standards.
Yeah. So it's called the Hypertext Transfer Protocol. And it basically sets up a protocol for the request of the
There you
packet,
go.
essentially.
Yeah. So a way that I might say that is a protocol for communication between clients and servers. And yes, Richard, you started to get into it. There's a lot of like specifications that go into this. What the format of these, what you call packets we are sending across the internet. I'll say like really just to keep it as simple as possible, protocol for communications between clients and servers. And I'll add in over the internet. You can use HTTP in other contexts, but almost always this is going to be where two entities are talking on the internet, clients and servers. Thank you, Richard. Let's go to Lawrence.
I would say that the request is typically a path with a verb attached to it.
So we're going to say it includes, I'll bold these, verb and path.
And because of what we're doing it in, it's set it as the HTTP. Sorry, that I butchered that sentence and now it's gone. It's a verb and a path for the server to act on.
Yeah, there you go. And the verb, yeah, so I could say the verb and the path indicates what the server should do. So like post to /artist, we're telling the server create an artist. Patch to /songs ID, we want to update this song. Get to /whatever, we want to retrieve that page. We want to view that page. So this is the main way we kind of like in our request, tell the server what we're requesting. Joe?
Yeah, doesn't the request and response also include like a header and a body? Usually a body, I guess, more so in the response than the request, unless we're like filling out a form or something.
There you go. So that's kind of like what we're going to talk about today a lot. I'll just say for now, like includes other things. And this is kind of what I want to get into more. The title of this class is HTTP request response anatomy. So the anatomy is like the other things the request could include. And I'll put this under response as well. So we really want to figure out what are these other things that they have. Great. And I think we've kind of talked about the verb and the path. So I think this is a really good starting point. Jen.
I was going to ask if you can tell me if this would compact it well for my notes. If I said user will send an HTTP request or a path verb from client, which will go to the server. Server will route appropriately using the controller action defined and issue a request back to the client, which will render for the user. Just want to make sure I have that down.
Yeah, that sounds pretty accurate. I might, for the purposes of this class, try to stay away from controller and other like Rails specific things. Okay. So the server, it could, in our case, yes, it's a Rails app. So we're writing Rails apps. We're running this as our server. So that has to, route through the controller and render a view and all that. But in just general terms of HTTP, the server, all it needs to do is send back an HTTP response in order to kind of fulfill this internet contract of what a server should do. It really just needs to send back that response. And that, you could write a server that just every single request it gets, it just sends back like a GIF of a cat emoji or a GIF of a cat or some sort of emojis or something. Like you could make your server do whatever you want. But yes, you are correct. In terms of Rails, we're going to route it to the controller and render a view.
Thank you.
Lawrence?
Does in this pact does it have to send back a response if you're clicking a button to update something in a server side and it doesn't have to render a view or change anything for you? Does it necessarily send back something? Will it always send back, hey, I got your thing and acted on it?
Yes, it always needs to send back a response. Even if there are responses and we'll get into this when we talk about like status codes. There are responses that just say like no content, that just say like nothing to see here, and that's it. But that's still a response. It needs to say something. If the server doesn't send back a response, the client doesn't know if that website is down, if there is a major internet infrastructure problem. Like the client just has no notion of what happened. It doesn't know if it was successfully received or not. So yes, in order to fulfill this, you called it a pact. I think that's a really good word, a contract. In order to act appropriately on the internet, a server needs to send back a response always.
Thank you.
So let's get into these parts, these anatomies of the request and response. So a request is going to include a verb and a path. More specifically, the request has 3 parts. So now we're kind of zooming in just on the request right now. So every request is going to have 3 parts. So the 3 parts are, number 1, the status line, or sorry, that is not correct, the request line. The second part of the request is going to be headers. And the third part is going to be the body, which is optional. And this is what Joe started to get into. The request line also has 3 parts inside that. So this also has 3 parts, which are the verb, the path, and the protocol. So we're kind of digging into these other things here. So every request is going to start with this request line, which has the verb and the path that we've already talked about, and the protocol, which is almost always HTTP 1.1. There are, I don't know too much about the plans. I think there is supposed to be an HTTP version 2, but I don't know if that's realistically going to be implemented. The protocol is almost always just this version HTTP 1.1, which is saying what language this, which version of HTTP this is written in. I don't really know about any other implementations of HTTP. So the protocol is part of the request line, but not super important. What we really care about here is the verb and the path. So now let's talk about headers. Headers are something that we haven't seen yet. So headers contain supplemental information about the request. So this is a part of the request that includes information about the request. So it is a form of metadata. This is the request telling you about itself. If this word metadata doesn't really resonate with you, I would say like just stick to this first line. This is supplemental information about the request. So for example, we could have things like, actually, I'll hold off on the examples for now. I think I'll have an activity later that should kind of show you some better examples. And then we are going to have a body. So the body, this is additional information the server needs to process the request. So here I can provide a good example. This is if our request is a post to /artists, indicating we're trying to create something. So based on our RESTful principles, this would be creating an artist. The body is where we would send over data like form input for the new artist's name. And let me rearrange my windows here real quick. There we go. So just to kind of summarize, the request line, and more specifically the verb and the path, indicates what we want to happen. And if what we want to happen is needs additional information, so for instance, like sending over attributes of a new or updated record, that data is going to go into the body of the request. All right, I want to pause here. What questions do y'all have so far? Joe?
The caching is like handled, or like yeah.
Joe, you're cutting out a little bit, but I heard you say something about caching, and I think your question might be like, how is caching implemented?
Yeah, is it like handled in the headers, or like what part of the three parts is it handled in?
Yeah, so caching, something we haven't necessarily talked about yet. Caching isn't going to happen in our HTTP requests, but something that could be stored, and you mentioned the headers, is cookie data. So cookie data is kind of how like websites can track some of your history and some of your preferences. So headers are going to be where that cookie data is stored. I don't want to go too in depth into that because that is going to be a topic in the beginning of Mod 3. Yeah. Caching, in terms of like the web, caching will more often happen inside the web browser itself, not through the actual request response. All right, let's talk about the response here. So what other things does the response include? So the response is also going to have 3 parts. So this mimics our HTTP request format where there's 3 parts. The first part is called the, why didn't I get a bullet? There we go. The first part is called the status line. The second part of the response is also going to be headers. So in the same way that headers for a request are information about the request, headers on the response are information about the response. And then we're going to have another part here, which is an optional body. So the body of the response is going to contain the supplemental information that the browser might need. And more often than not, this is going to be where we're going to get our HTML, our CSS, and our JavaScript. We haven't done JavaScript in Mod 2, but this is where the visual components that your user wants to see are contained. So this is contained in the body of the request. Now, sometimes the response is not going to send back a body for reasons, and I'll do an exploration later that should kind of show an example of that. The status line, just like the request line and the request, also has 3 parts. So this is going to be a status code. It's going to have a status description, and it's going to have that HTTP, or it's going to have the protocol, which again is almost always HTTP 1.1. So status codes and status descriptions are, they indicate what happened with the request. So for example, some just like kind of key status codes to know, 200 equals okay. And the status, when I say okay, that is the description. So think status code is machine readable, it's a number. Description is human readable, it's a word. So as I'm doing this equals, this is kind of like code and description. So 200 okay is just everything went well, here's your web page. There is a 404, which y'all are probably have seen before, for not found. So a 404 is really indicating something's wrong with your request. You're trying to request something that the server doesn't know how to process. This would be you're sending a request to a Rails app and we don't have that route defined. A 500, I'll say 500s. So all the 500s are server errors. So the first number here really indicates like the category. So typically anything in 200 is good to go. Anything in 400 is client error. Anything under 500 is server error. So that's like an error in your Ruby code, or you know, something wrong with your SQL, or just something happened where the program on the server side errored out and it's sending back a 500 level status code, which means, hey, we did something messed up on our side, on the server side. Alex?
Yeah, would you ever see this 200 pop up? Like, my assumption is you'd just get whatever you were looking for. Like, if we wanted to, I don't know, if there would ever be a situation where we needed to check, like, if like half of our shit showed up, or I have no idea, but like, would we ever see it?
Not for a 200, because as you're saying, like if everything's good to go, it's not going to say, hey, everything's good. You're going to know it by seeing the web page. 404 is one you probably have seen, because that's what will be displayed to you. So like if I go to github.com/gibberish, it's going to say 404. This is not the page you're looking for. So yes, good point, Alex. Some of the activities I want you to do today should show you where the status code is found. But for now, this is probably one of the only ones you've seen. Actually, you've probably seen 500 server errors as well. This is when like a website is down or something. Other questions so far? All right. So just to like really drive this home, I want to draw my diagram, which I've drawn plenty of times. So I'll try and draw this pretty fast, but we've done a lot of text descriptions. Let's get some visual description here. So we've got a client on the left, a server on the right. The client is going to send that HTTP request. And that request is now, as we've talked about, is going to have on the status line verb, path, and then I'll just put in HTTP 1.1. Then it's going to have headers is the next thing. And then it's going to have a body. Our server is going to, as I think Alex said it earlier, do some magic to figure out what it needs to do with this request and then send back a response. And that response is going to have status, code. Let's actually just say code, description, and then also HTTP 1.1. It's also going to send back headers, and it's going to send back body, which is where our HTML is located. So then client receives back that HTTP response, pulls the HTML out of the body, and that's what it displays to the user. And we've got human user. There's our user. There we go. And I think that's everything that we've talked about so far. All right. So let's go ahead and take a pause. We'll come back at 1:35. And I will real quick, I'm going to drop a link in your cohort channel, which shall give you some more description of HTTP status codes in hopefully a fun format for you all. So let's come back at 1:35. All right, I'm going to get started back up here. So yeah, the link that I dropped to you was these HTTP status dogs. This is nice to just peruse once and get familiar with the potential status codes that you might see working on the internet. Let's go back to our notes real quick. And I don't think we need to go into the HTTP verbs or anything like that. I think we covered most of what I wanted to. So yeah, this is a good start here. Right now, we've been talking very conceptual. Okay, well, our request is going to have this part. Our response is going to have this part. But now what I want to get into is like, can we actually see some of these in action? So there's a tool that we can use called curl. So curl is it stands for client URL. So that's where you get CURL. So as we've discussed up to this point, the client is the thing that sends an HTTP request. And normally someone using a web browser would accomplish that. And the web browser would send the request for them. But there are many other ways that we can send requests. And one of these is curl. So this is a command line tool. And the advantage of it being a command line tool is that you can use this in almost any environment. So anywhere where you have access to a terminal or the command line, you can use curl. The disadvantage of it is it has some like limited uses, and it is syntax can be difficult. So the curl is really going to give us like a quick and dirty way of sending a request. So when I say client URL, when we're saying client, a client is really just anything that can send an HTTP request. So let me show you how this might work. Oh no, that's not what I wanted. Here, let me stop my share very briefly and pull up a different app. Sorry about this, I was in the wrong directory. Okay, so I've got my terminal pulled up here, and I've navigated to my setlist directory. I'm not going to need it at the moment. The first thing I want to do is just curl. So if you just type into the curl, if you just type curl into the command line, you should see like a help thing. And if you type in curl help, or it looks like curl dash help, it'll give you some more information here on how to use curl. And this is kind of where I start to get into like, I don't know how user friendly this is. I don't know if I want to just read this giant wall of text to figure out how to use this thing. The easiest way to use curl is to say curl dash V, and V stands for verbose. And I want everybody to go ahead and type this out in their terminal as I'm doing it as well. So curl dash V, and then we're going to give it a URL. So for instance, we could go to google.com. And we could leave off the whole like, you could potentially do like http://google.com. That would also work. And what we're going to get is our requests and response in action. So I want you all to take a moment looking at the notes that I have given you and looking at this response from google.com. I want you to identify each part of the request and response. So where's the status line? Where is the description? Yeah. So take a couple minutes for yourself, and I'm going to make some breakout rooms for you all to discuss with some small groups. Does anybody have any questions on what I'm asking you to do? All right, just let me know. Take a minute to yourself to really break down these requests and response. Something else that you will find helpful, the request is all of these lines with the, the request is all of these lines with the right arrow or the greater than symbol. That's all of the request. And then the response is everything with the less than left arrow. So you can kind of think of it as arrow right is going out, and that really aligns with my diagram that I showed you. Right is the request and left is the response. So what I have, I'll just leave the response or the request highlighted. All right, so now that you've had a minute to look at this by yourself, I'm going to put you into some breakout rooms. So with your teammates in your room, try to identify all these parts of the request and response: the request line, verb, path, protocol, headers, body, and then very similar for the response, status line, including the code, description, the protocol, the headers, and the body. Try and identify all of those parts together, and we'll go over it when you come back.
supplement. So I think that there's like even above that, because this part is the with the arrow.
Not modified.
Thank you, Natia.
I love how the recording starts right when I point that out.
Because I'm assuming you can't, I know you can.
I'm just looking at the dogs now.
Brian, we found HTTP2.
We did.
Don't know how. There it is.
How about that?
In a sea full of 1.102, Noah.
What did I do? Why
How did
that
you do
happen?
that?
I don't know. I typed this command in, and then all this happened.
Yeah, but we all did www dot the second, like, because experiments. But it says and offering H2, offering HTTP 1.1. Maybe it's just you conflated H2 and 1.1.
I tried it on a different website first. Maybe I have two like living searches going on right now or something like
No, I've got 8. I've got the same line, but mine says 1.1.
that. But I did like a different website.
Oh, what we want.
Go-
No.
Noah,
It's a really long one, so I
Noah,
did
go
this
back.
website.
If you can send Google a search, I think that's Google from the future. You can find out how to save us.
Skynet. Okay, I'm done.
You're done, Alex, we love that about you.
I just wanted to see a real website, but I got a massive response that I couldn't see the beginning of.
That's what a real website looks like.
I just see bronze, brunettes, redheads.
Nice Matrix reference. I like it.
Did I do? Oh, maybe it's because I did HTTP. That's
Yeah.
The get HTTP 1.1 is the request, like towards that's the request request line. That's the words.
Yes, the verb is the get.
The path is backslash.
The protocol HTTP 1.1.
Yeah, so the first line of the response is just the protocol, but more importantly, the HTTP status code that's being sent with it. No, it totally just lost out of my head.
I was thinking where it says content type and location and date, all that, that looks to me like metadata. So that's going to be in the header, right?
So then to be clear, for the request, kind of going back up to that, the host, user agent, and accept, those would be the headers for the request, correct? Okay. And with that one, it looks like we don't have a body. So that's like this optional body, correct? Thank you. What about put? Would that, does that kind of just depend, or would that like typically have a body as well? Okay. Rad, thanks.
Maybe just whatever's inside those HTML tags. So if you were to go into your, what do you call it, a search bar? The place where you put the www URL bar, and you were just to do google.com. Does it hide the rest of that in there, the HTTP :// yeah, and it just, is it just something that was added later for ease of the user? So is it even possible on your URL bar to go? Oh. Okay. Cool, thank you.
You're definitely not. Yeah. It was a kind of question. I was just wondering if what you were talking about is how things like Bitly works and like URL shorteners, but that's. Oh, I probably can find one pretty quick. Oh.
So I was just speaking to Bitly. I do know one way that that works is that your traffic is routed to the Bitly servers first to gather all of that metadata of like, oh, where did you come from? All this other stuff, and then it redirects you to where you want to go. And that's how those link shorteners work, because a lot of them are like affiliate links and they want to collect the data from where, you know, their users come from and stuff like that. So it's like one server and then redirects it.
Yeah, I think they just called you out.
All right. Thank you all. I thank you, Jen. I saw in the cohort channel some more context for the email question. Yes, I'm definitely a just let it sit in the inbox person. So, all right. So I dropped a Jamboard for you all. I can share my screen. Really, what my idea for the Jamboard for this session on APIs part 2 is really meant to like let you all drive some of the conversation. So you can kind of think of this as like a parking lot or a like question backlog. I have a couple things I want to talk about first, and I'll kind of like live code, but you all have access to this Jamboard. Feel free, like as I'm talking throughout the class, to add your questions here. And then when I kind of cover the things that I want to talk about, then I'll kind of use the Jamboard as indicate to me what you all would like to talk about. So the first thing that I really want to get into is first of all connecting this back to like what we just talked about in terms of HTTP, and a little bit more on like Rails specifics and what this might look like in Rails. So yeah, go ahead and start adding your questions here, and then we'll kind of circle back to that later. Does anybody have any questions about that before I move forward? Okay. So let's talk about why that HTTP jargon that we just talked about is relevant. I want you all to take I want you to take maybe 30 seconds to think for yourself, think through this question. Everything that we just talked about in terms of HTTP, how does that change if we're interacting with an API? So that's a very broad question. Maybe something that you can do is like pull open this document as you're thinking about it. How does this information change when we're working with APIs? That's kind of that's a big question. I'll give you all a minute to think through it for yourself. All right. So now that you've had a minute to think about it, I want to cover some key concepts here. So I'm gonna take a red cursor here and kind of use red to indicate how all of this information might change if we're working with an API. So if we're using an API, the client in this case, or sorry, the user who is the person using the client, can I make that red? Let's actually just do this. So now a user is no longer, is still a human here, but this is typically this is a developer. This is somebody who has some sort of like knowledge of an application, inner workings of code and APIs. Now we're not just thinking of like any human, any person who wants to use our website. If someone is trying to use an API, they're typically some sort of developer, maybe like engineer would be another good word to put here, but someone with some sort of like background knowledge in HTTP. The client still sends an HTTP request to the servers, and a lot of times this is a web browser, but when we're working with APIs, we are getting information to be processed not by human eyes, we're getting information to be processed by code. So the client is usually not a web browser, which has a visual component. In APIs, when we're working with APIs, this is a some sort of I don't know. I'll just say this is what's a good way to describe this? This is, well, actually, let me ask you all this. In our examples that we've shown so far, what client are we using to send requests? Go ahead and raise your hand if you know the answer. Alex?
This is a pure guess, but the server is the client, isn't it? I don't know.
I can see how you can get that, but that's not exactly what I'm saying. What is the tool that we're using to send requests? Jen?
Is it your app?
Not quite. We're sending the request from the app. And I'll give you a hint. It's in this file here.
Is it JSON?
Not quite. Molly?
Is it the gem? Like, is it because it's going through Faraday?
Yes, it is Faraday specifically. So in APIs, this is well, actually, let's just say in mod 2, this is Faraday. So Faraday, the whole purpose of using Faraday is that it's a gem that we can use in Ruby. So this is the key part here, that we can use it in Ruby. Because if we can use this in Ruby, then we can also process the response in Ruby and do something like that, whatever it is that we might want to do. But the key here is that we can manipulate the data in our code. So this is where it really starts to be, where it starts to become important. You can consume an API from the web browser. I can go to get API dot, well, let me go over here. This URL, I can consume this over here and just put in my username. But then what do I do with that? A web browser kind of ends at, here's the visual representation. By putting this into Ruby, now I can use my code to process this even further, which is what we're doing over here in our app. This is all the code that we left off with the last time. Another thing that kind of indicates that Faraday is our client here is this GET request. So Faraday has a method on it called .get. When I call .get, this actually sends a request, and the return back from that request is this response object. So going back to my notes here. So when we're talking about in mod 2, let's say mod 2 and APIs, this is Faraday. Really, a client can be anything that's sending an HTTP request. So the server is still going to send back an HTTP response. Yeah, the request, we're still going to have a verb and path. We're still sending a GET request to api.github.com. It still has the request line. It still has the headers. We still have an optional body. We still have all of that stuff. Response is all exactly the same. I would say the only thing that changes is this part right here. If we're working in APIs, we don't want to get HTML back because that is very hard for us to process in terms of our code. So this is where the change is to JSON. So when we're working with APIs, an API is going to send you back JSON because that's much easier for you to parse through with a programming language. So the point that I'm trying to make here going through all of this with you is not a lot changes when we're working with APIs. It's still a very similar interaction where we're sending we're using a client, we're sending a request to a server, expecting some data back. It's just now we're expecting back raw data in the form of JSON that we can parse rather than HTML, CSS, JavaScript, which has a bunch of like presentation logic in it that we don't care about. And rather than sending the request with the web browser, now we're doing it with another client, which in our case is Faraday. If I go back to my diagram here, and then I'll get to your question, Alex. Oh, I don't have my diagram anymore. That's a bummer. But if I was going to draw the diagram, I'll just do it here as fast as I can. Diagram is going to look exactly the same. It's just that now that our client is Faraday, we're sending a request like this. It still has all of the parts of our request. It's going to hit some sort of server, which is managing this API. We're going to get back a response like this. And that response is going to contain now, rather than HTML, this is going to be our JSON. Alex?
Maybe that answered my question. I was wondering if there was an easy way to go between HTML and JSON, just like if you were making an app and all of a sudden you realize like you want to integrate this API, like, is that not something that you'd have to deal with? Or is there some way that you'd have to then like reconfigure or something like that? Or like, did I like miss a point?
So if you're consuming an API, that API will not send you back HTML because it is very hard to the answer is no, it's not easy to translate between HTML and JSON. And so if you, that's why we have separate, the APIs are typically a separate piece of an application. Just to illustrate that, that's why there's a whole api.github.com. api.github.com, completely separate from github.com. GitHub.com is the like user-friendly, human usable part. API.github.com is the machine-readable JSON meant to be processed in some sort of like programming language. Mark?
I'm just curious with that. It seems like this is like a standard format in terms of like key values, and then you have like a comma. So it seems like JSON or Faraday helps translate that into code. Is there like others? I guess there might be other gems or programs that translate unstructured data, or am I like far off topic?
I don't think I quite understand your question. What I would say is that there is no such thing as like unstructured data. Like that's almost the point of data. Like data is like structured, meaningful values. So every API is going to have some sort of format that it's going to follow. And any modern API is going to typically stick with JSON. Other formats are XML. That's probably the other most common one. Compared to JSON, XML is just like not that pretty. I'm wondering, can I throw on .xml at the end of this and get? No, that's not going to work. Mark, does that help you clarify your question?
Yeah, that does. Thank you.
Okay. Molly?
Yeah, I have a question kind of about so like the API is not the actual server that is sending back or like taking in that request and getting back the response, right? So like api.github.com and github.com are theoretically like, would they be using the same server, I suppose? And then like the API is what's like, I guess I'm like maybe trying to ask like how like our client or like how Faraday is understanding that it needs to contact like the API and then like get to that same server, and is it just because you're going to this like api.github.com and like, yeah, how do those things like differ? Maybe it seems like there's an extra step in that process that's not in that diagram.
Yes, you're right. There are extra steps in this process that are not in the diagram, just to like simplify it. I think what, let me just say this. GitHub.com and API.github.com, those are like very similar URLs, but what's behind those URLs is like totally up to GitHub to manage. It could be the case that they are like connected to the same database. It could be the case that there is actually a third application that's just responsible for managing that data. It could be the case that the API.github.com is that application that just manages the data, and GitHub.com consumes API.github.com. So it could be, if I go back to my whiteboard here, it could be the case that this, if this is like in this example, this is API.github.com. This thing could be connected to a GitHub database like this. That's where we'll just call this like GitHub's database. So this might be the interaction right there. It could be the case that the way GitHub is structured is that there is also GitHub.com, and GitHub.com could talk directly to that database like this, or GitHub.com might go through API.github.com to get that data. Those are like two different architectural patterns. And this is starting to get into this idea of microservices, that GitHub might be composed of many smaller services like API.github.com.
Okay, cool, thank you.
You're welcome. I'm sure that this is very confusing at this point, and this topic of like microservices and app architecture, that's going to be a bigger focus of Mod 3 and Mod 4. I want to kind of shift gears back to our code and try and make this a little bit more practical for you all. So I mentioned how Faraday is a client, just like our web browser is a client. It's sending an HTTP request. And we can see we get back a response from that. And look, the first line underneath that is response.body. So this is another connection to what we just talked about. The data, the meat of what we want to get back is going to be stored in the response body. I also showed you last time how I was digging through response.headers as well. So I don't want to go through all of the GitHub documentation with you all, but I just want to kind of point out some things here. So when we're looking at resources and the REST API, and we're reading through this documentation, it'll say things like for authentication, OAuth 2 tokens sent in header. So this is another place where that HTTP anatomy comes into place. So I would have to know what a header is in order to send that over as a header. Let's go to the section on rate limiting. Where is that? Rate limiting here. And it'll say down here, the returned HTTP headers of any API request show your current rate limit status. So last time I showed you, I was doing like response.headers. I didn't just know that off the top of my head. I looked at GitHub's documentation, saw that those were stored in the headers, and looked at those headers to find that data that I wanted. So this all is to say that learning to like kind of speak the language of HTTP is very important, especially as we work with these APIs and we have to dig deeper into this documentation and really understand what this documentation is saying. Joe?
Yeah, on that page, I noticed that use the verbiage REST, and I've like heard people refer to APIs almost as just like REST by itself. Obviously in our application, or applications, I should say, we kind of follow that architecture. Is that basically just like all APIs, or at least most, like follow that architecture, or like, is that the deal, or how does that work?
Yeah, I would say that REST currently is the standard for how you build an API. So we've talked about REST as being like just formats for your routes for them to make sense. So if I'm posting to /artists, if it's RESTful, I know that should create an artist. So yeah, REST is just like a way to design your application. So if you're building an API, you kind of, and you say, I'm going to build a REST API, you kind of have like a full guidebook or like a playbook on all the things that you need to create, or all the things that you need to create. So it kind of just takes away those design decisions.
Gotcha. Yeah, and I'm sure it probably helps with compatibility like across the board as well. Thank you. You answered my question.
You're welcome. Any other questions up to this point? All right. Let's keep going with a little bit more with hopefully something a little bit more practical. So what I want to do now is I essentially want to like refactor my API project to be a part of a Rails app. So I'm going to run Rails new from the command line, and let's just call this, I don't know, I'll just call it API. And I will make it, I'll say -d equals Postgres -t to skip mini test. We want to skip Spring. We want to skip Turbo links. And I think that's everything I need. So I've created a new Rails app. Let's CD into it. Let's create a database. And let's run Rails S here. And so now I should be able to go to localhost 3000, and then it'll say, yay, you're on Rails. This is great. Let's do, okay, so I've made my app here. Let's make a route. So let's open up routes.rb. I don't think it's indexed yet. And let's make a route. I can use this helper here. This helper to just make that route path. So as I mentioned before, the route is just kind of like the landing page of an application, or like kind of the starting page. In the context of a web app, that would be the landing page. So I can use route to, and let's make it a welcome controller index action. So now when I refresh this page, whoops, I need to keep my server running. So now it'll say uninitialized constant welcome controller. So this is a quick way to spin up this landing page. So we'll make a new file here for welcome controller. And then this will be class welcome controller, inherit from application controller. We'll make a def index in here. And then I'll refresh the page. And this is typically I just see this error and I say no view, I need to go make my view. But we can just stay here for 1 second and notice this action would normally respond with 204 no content. So this is just some more examples of those status codes coming over through. So 204 no content in empty white screen. So if you expect a 204 no content carry on, that's what you'll get. Okay, so I want to get past this error. I want to create a folder, which is going to be welcome. And then inside there, index.html.erb, and refresh. And that will just give me my blank view that I've just made here. Okay, so now what I want to start to do is I want to start to move my code into my Rails app. So I've got this one class for API, which looks like it just gives me, it prints out a bunch of stuff. And then I've got another class for GitHub service here. So conventionally, what you'll see in Rails is you'll see a folder. So I'm going to make a new folder under app called services. And so what I'm going to do is I'm just going to take that GitHub service file and just drop it right in there. Failed to move. I don't think that's true. I think it moved. I see it right there. So I've got a service file called GitHub service. And what this allows me to do is it allows me to call this class anywhere inside my code. Any file that you put under the app directory will automatically be loaded and you'll get access to it. So just by the virtue of being it under app services means that I can access this code from anywhere. I'm going to take out the pry in here as well. And then let's look at the other file that I have. So this file API and then self.run looks like it grabs our user's info and then it returns this like hash here. Well, actually, this isn't even a hash. It's just printing out a bunch of stuff. So that's actually not super useful. I think I'm just going to abandon this file and not really use that. What I do want to keep is my GitHub service. And now that I'm in Rails, I don't want to require these files anymore. I want to put them in my gem file. So that was Faraday and JSON. I don't need to add JSON, but I do want to add Faraday here. And I'm putting it outside any of the development and test blocks because this is not something that I just want to exist inside like the test. I want this to be accessible from all environments, including my production Heroku environment. So now that I've added something in my gem file, I'll bundle. And I'm gonna reopen Atom here because I just want the Rails app. I don't need the other stuff anymore. And just to pick up where we left off, I'm in the gem file. I've got Faraday in my gem file right here. And I've got my GitHub service over here. So just to test that this is working, I can go into my new view right here. Let me split the screen here. I can call, or I can make an ERB tag, and I can call or try to call GitHub service.user info. And it looks like I need to pass my username as well. So I'll just pass it in Brian Safety. So let's run our Rails app again. Refresh this page. And now I can see that raw hash of data being displayed in my view. Now I could, if I wanted to go a little bit further, let's just say I want to do something very similar to my last APIs class, which was display my number of followers and the date I joined GitHub, et cetera, et cetera. So I could do all of that in the view here. I could say, okay, well, this is a hash. So let's iterate over this. Actually, let's use hash bracket syntax here, and let's grab the login, or actually, let's grab created at, and we can interpolate date joined GitHub like this. And I'll just take that method call, put it inside my interpolation here, maybe wrap it in a p tag too, just so it displays a little nicer. And there we go. Now I'm starting to incorporate this data inside one of my views. Now, what I don't like about this is it's not following kind of like my core principles as a programmer, one of those being abstraction and encapsulation. So abstraction is this idea that, that the details are kind of hidden away from us. And encapsulation is this idea that data is kind of wrapped in appropriate wrappers and is not like leaking over into different parts of the application. So I would say this right here is not very abstract or encapsulated. The details are kind of just like, it's kind of abstract in the sense that we have this GitHub service class here, but even the details of like this being a hash and having this created at here, not very abstract. And also this data is not encapsulated. All of this data for my user is just kind of like stored in this one big hash. What I would prefer as a developer is to use more, an object-oriented developer, I prefer to take more advantage of objects in this case. Jameson?
Yeah, I guess that kind of segues into my question. You made user info a class method. Is there like an underlying reason for that, or is it more flexible? And I guess, would you ever make instances of GitHub service?
The reason I don't need it to be an instance is because it doesn't need to keep track of any state. So state is some sort of like attributes, variable data that needs to be kept. In this case, we're not really keeping track of it. We're just kind of retrieving the information once and then processing it immediately. If I did something like this, if I also wanted to say, do something like date, no, what did I say? Like, I'll just say like your name, because I think name is another one of these things. Whoops, name. And let me just see if that works. Yeah, there it is right there. So this will work. This is the point where I would say, maybe I want to make this an instance method, because notice how I'm calling this method twice. So that's really inefficient because we're hitting GitHub's API twice. Does that help, Jameson?
Yeah, it does. Thank you.
You're welcome. So this code is not great for all the reasons that I've talked about. So I want to refactor this a little bit more, and I'm going to do that by dream driving it. So I'm going to imagine there is a method that I can call. Actually, let's do it like this. So Jameson, I think that is a good segue. Let's imagine that there's an object. Maybe we'll call it GitHub info that I can call methods on. So let's say I want to find my, I forget what all the things are. We want the date we joined GitHub, our username, and let's just stick with those two things for now. So wouldn't this be so much better if, rather than interpolating GitHub service.userinfo Brian Zanti bracket name, if there was just an object here that we could say at GitHub info dot name. And same thing up here. What if there was some really nice object where we could say at GitHub info dot date joined? Wouldn't that be nice? I'm going to go ahead and take a palm here, and we'll come back at 2:55, and we'll start to fill this out a little bit. So we can see we're going to get some errors for that. We're going to work on those errors next. All right, everybody, I'm going to get started back up here. Natia, do you have a question?
I do. When you're doing something like this, if you are getting an uninitialized constant error, what kind of things would drive such an error?
So good question. I think like understanding your errors is really, really key to any programming language or any tool that you're working with. Uninitialized constant means that whatever context you're in, you don't have access to that thing. So if we have uninitialized constant GitHub service, that would tell me that my app can't figure out what GitHub service is. So a lot of times a spelling error is what will produce that. So if I just like left off the A here for Faraday, it would say uninitialized constant Faraday. Yeah, so usually sources of uninitialized constant are spelling errors. I think that's the most common thing. Outside of Rails, it's often require errors. So if I am outside of Rails, I have to require files in order to get that code in that file. Does that help, Natia?
Yes, thanks.
In Rails, if I'm getting an initialized constant, if it's not a spelling issue, the next thing that I would probably check would be my gem file, because my gem file determines what gems I'm pulling in. So for instance, if I had uninitialized constant Faraday, I would want to double check that I have the Faraday gem installed and in the right place. Just to dig on that a little bit more, the right place, if I put gem Faraday over here in development test, this might be fine for when I'm looking at local hosts, but as soon as I push it up to production on Heroku, now I'm not in development test. So if you get issues with uninitialized constant Faraday and Heroku, that would be my first guess as to why. Okay, so let's keep going with our dream-driven refactor here. So I'm trying to imagine there's this GitHub info date joined and .name method that I can call. But if I go over to my view now, I'm very much doing browser-driven development. I'll get undefined method date joined for nil class. So my at GitHub info is nil, which makes sense. I just haven't set it up. So I could go to my welcome controller and I could create it here. I could say at GitHub info equals, and now I have to make another dream-driven decision here. I have to figure out what actually do I want to create here. So I'm imagining it's an object that has these methods that I can call on it. So I think I'm going to have to create an instance of something, and maybe I'll call this, let's call this GitHub user. That makes sense to me. So as I'm thinking through encapsulation, I'm really thinking about like a container for all this data. It makes sense to me that the container for my user info would be a user object. So I'll create a GitHub user.new. And I think that might be all I need. Yeah, let's roll with this. So now I'll refresh again. And now I'll get uninitialized constant. And just back to Natia's point about like how to interpret uninitialized constant errors. When you have this syntax of something : something, that means within this thing is not defined. So within the welcome controller, GitHub user is not defined. So I'm going to need a GitHub user class. And here's another pattern that you'll see in Rails. If something doesn't really fall under any of these categories of like services, models, mailers, jobs, etc., typically we'll have another folder called Poros. And Poros stands for plain old Ruby objects. So under that folder is where I'm going to make GitHub user.rb and my class of GitHub user. And you can see how this is a Poro, a plain old Ruby object, because it doesn't inherit from application record or application controller or anything like that. So now I'll go ahead and refresh this page. And I'm still getting uninitialized constant GitHub user. Did I save? Why isn't this working? Okay, let me put this over here. GitHub user, GitHub user. So I don't even get an uninitialized constant error. Yeah, so if I don't get, or if, so I'm not getting an auto load error. So if an auto load error would tell me that I had the file spelled correctly, I think what I have to do in this case is I think the reason this is happening is that I have to close out of my server and rerun it. So I think anytime you add a new folder, I think you need to rerun your server. That might be true for files as well. Let's see if that fixes our problem. Yeah, it did fix our problem. There we go. So I'm not sure if that's files or folders, but I had to restart my server to get it to pick up this new file that I made. Okay, so now it's saying undefined method date joined. So it looks like I was able to create a GitHub user object. It just doesn't have that method. So let's go make it. So we'll make def date joined. And let's also make, what was the other thing that I needed? .name. So let's make def name as well. And there we go. I've made all the elements that I've needed. It's just that these methods are blank and they're not returning anything. So I'm just displaying some blank data here. So how could I fill in these this data here? Well, let's do this. Let's say, let's make an initialize method. Initialize, don't want to spell that wrong. And let's use our GitHub service class. So let's say GitHub data equals GitHub, looks like lowercase h, service dot user info. And then it looks like I also need to pass my username here. So I can pass Brian Zanti. And then let's say at date joined equals GitHub data, and I believe the key was called created at. And let's do the same thing for name. I believe this was just called name. So when I make this object, I'm going to pull the data from GitHub. I'm going to set up 2 instance variables. And so now my methods can just return those instance variables. Let's put return here. I feel like this is something I don't do often. Let's just make an explicit return. And so now I'll refresh the page over here and I'll see those 2 pieces of data filled in appropriately. Additionally, because I have methods that are returning instance variables of the same name, these are essentially the same as adder readers. So I could replace these with adder readers. And refresh my page and make sure that's still working. So if I kind of pull all of the code together that I have, we'll do, I'll leave that up there. I can see my code is a lot more abstract and a lot more encapsulated. It also just reads better. It's more reusable. So if I needed to put this code in other places, I could just instantiate a new GitHub user like this and use it other places. Yeah, this is all like much more SRP. It's just kind of like following all the things that make me happy as a developer. Just to make this a little more flexible, upon initialization, I could take in that username over here, just to make this a little more dynamic rather than having Brian Zanti hard-coded over here. And so then maybe I'll do this over here. When I make a new user, I'll give it the username, which makes sense. That makes more sense to me. When I make the user, I tell it what username I want to use. GitHub will hit the GitHub API through our service object, and we can pull out some data like this. My next steps would be to test. So I'd want to add a test for this GitHub user class. I've already had a test for the service outside of the Rails app. I probably just translate that test into a Rails test, which would be almost identical. And I think that would be about it. Probably add a feature test for this as well. And then additionally, if I wanted this to be on every single page, I could consider factoring this into an application, refactoring into an application layout rather than an individual view. All right, y'all, so that will do it for everything I wanted to cover. So for the rest of the class, this can kind of be like office hours for APIs. I'll take Jameson's question. We'll look at the Jamboard to see if anything came up there or any other questions that you all might have. And if you're feeling really good and you want to head out, that is fine as well. So Jameson.
Yeah, so in your GitHub service, when you're connecting, you've got the possibility of getting a different response other than 200. Can you speak to how you would handle that? Whether it's through an error or whatever?
Yeah, that's a good question. How would I do that? So I think what would happen if I got, so this class right here, and this is kind of getting into the idea of SRP and why we want to separate responsibilities. This GitHub service class is just responsible for hitting the API. It doesn't process the data other than to just like turn it into JSON. It doesn't like check anything with the data. It just takes the data and returns it. So I would say the point where I need to, where I would need to check on that would be here in my initialize method. I think what I would do here is I would do something like this. I'd probably make a new method here for, maybe I'll call it like validate user, or maybe I'll call it like validate GitHub data, and I'll pass GitHub data over here. And I'll take out the view now. And then I can make that method in here. So I'll say validate GitHub data. We'll just pass in that data like this. And then I think I would open up a begin block here. Actually, no, I don't think I need to do that. I think I would say if actually, I don't even think I would need to do it like this. I think I could just do it like this. So I could say like validate GitHub data, and that method doesn't really need to take in this data. I could just say inside this method, if at date joined is nil or at name is nil, then I could return. Actually, let's do it like this. I'm going to make a method called valid ? And if either of these are nil, it should return false, indicating it's not valid. Otherwise, we can return true. So I've hard coded this right here. I've hard coded this username into my controller here. But let's just say, actually, let's do it like this. Let's make a route, and let's make resources GitHub users only show, and let's make a new controller for this. So GitHub users controller, GitHub users controller inherits from application controller. I'll make a def show in here. I'll make a GitHub users folder, and I'll make a show inside that. And yeah, I'm really like not TDDing at all. So this does feel like a little fishy to me. It feels like not great that I'm doing it without test, but I think this is a good example. So now what I'm imagining is there's a route where I can pass in as user input a ID for a user, which could be just the username, like that. So now what I want this controller action to do is I want it to say, I think I'm just going to copy what I had in my welcome controller and put that in my show view. So it's going to be very, very similar, except now GitHub info is going to equal GitHub user.new, and I'm going to take that ID that I'm passing through the params. So now I'm accepting this as user input, which is coming from my route here. But if someone passes me something, a GitHub user that just doesn't exist, it's going to return nil, like so. So then what I could do, or this data is going to return me nil, or more specifically, this data of the date join, that's returning nil. So then I could handle that in the view like this. I could say, if at GitHub, and I'm calling this GitHub info, I think I prefer to just call it at GitHub user. So let's change that. Change it here as well. So I could say if GitHub user dot valid, do this otherwise. Maybe we'll just say p tag like invalid user. So if I pass in Brian's ante, it's all good to go, but then I pass in gibberish, it says invalid user.
Hell yeah, that was awesome. Thank you.
You're welcome. I'm glad you enjoyed. There could be potentially some use case for begin and rescue blocks, which is how you would catch an error in Ruby, but I don't see any place where I would actually be throwing an error. It's just the data that I get back is not necessarily what I want. Noah.
I was unaware that I had raised my hand. I think that was a mistake.
No worries. Let's check in on the Jamboard, see if anything came up. All right, so great. I see these first two. Where should they live in Rails? What do you want to see for testing on an API in our project? Okay, so I think we covered this, where should they live in Rails? For testing an API, I would say for this project and for where we're at in mod 2, we really just want to see you consuming the API. I think in terms of testing, I showed you all, I mentioned this before, but we wrote a test last time. So yeah, I think I'm just from the command line going to cd out of this directory because I have a spec directory. Yeah, so I have a GitHub service spec already. I think what I want to do is just, can I just open that in here? Yeah, let's just open that. I don't necessarily want to move this over to my Rails app yet. Yeah, I'll do it. I will do it just for you all. We'll add in gem rspec-rails. We'll run bundle. Could not locate gem. Oh, I'm in the wrong directory. Let's just go back over here. We'll bundle. I'll run rails g rspec install. That'll set up my installs for me. Then I'm going to make a directory inside spec for services. And so now I'm going to move /spec/GitHub services to my new spec services directory. There we go. Okay, so now I've moved my test file over here into services. I don't need to require because I'm inside Rails now. And my test, this is really all we need for a service test, is we need to hit the API and just expect it to have some data. When you're hitting an API, that data is dynamic. You're not really controlling that data. So you don't want to do something like expect JSON to equal, or maybe like JSON created at to equal, you know, whatever, 2014 dash whatever, 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 the exact date, because this data could change. So if for whatever reason, like maybe I leave the team and we can't use my username anymore, we would want this to be a dynamic test. And as we talked about with the last time, I really want you all to incorporate what you learned in Mod 1 about RSpec mocking and stubbing, which was this line right here, to prevent yourself from overloading the API. Because as we talked about, the API is rate limited. You can only hit it 60 times in an hour. So if you have, we did ask for this to be on every page. So if you have 60 tests, you would just use all of your API requests in one test run. So make sure you're implementing your mocking and stubbing. And now that I have this GitHub user, I think I would test this as well. So I could, let's make a new folder for Poros under spec. You could also put this in models because it's kind of like a model. But you could also do it like this. So I could say GitHub user spec.rb. And then in here, I forgot to require my Rails helper in the other one, but you would want to do that as well. Let's just do that. Require Rails helper. So in my GitHub user test, I can do rspec.describe GitHub user. And then I would write some tests for it as data. And then probably for my valid method. So it can be valid, and probably another test for it can be invalid. And because my GitHub user class accesses the GitHub service, I probably want to include my stubbing, my mocking and stubbing over in that test as well. So any test that could possibly hit the API, I want to include, sorry, I've got too many files open. Any test where it could hit the API, I want to make sure that I mock that out. So then I could say user equals GitHub user.new. And then I can expect user.name.to equal Brian. And I think that would be enough to get you all started with testing. Let's see what my tests do. Wow, I can't believe that all worked. I was definitely expecting to run into something, but yeah, I think that's how you would do it. I think that kind of covers the testing. The only other thing I would want to add is probably a feature test, but you all know how to feature test. That would be, I would just want to expect the page to have content of whatever the GitHub stories say they should have. Molly.
Hey, yeah, I have a question about the test on the GitHub service level. So it makes a lot of sense to me to mock and or to stub that method user info on this on the like GitHub user spec, right? But on the GitHub service spec, when you mock that, all your testing is that you've mocked it correctly. Am I wrong? Like, I guess I'm like in this case, it doesn't make a lot of sense to me to do that test here. And I'm curious about why, because I feel like you just put mock data and then you're like, is this mock data formatted the way I said it is?
Yes, you're exactly right. This is not really testing anything other than, yeah, okay, so this test is very minimal, right? It's not really, it's not a good test at all. You're right. It is, we're mocking out, you should never mock out the method that you are testing. For instance, user info, that's the thing that we're mocking out. Really, the point of this is just to kind of set you up nicely for mod 3 testing. The other thing that this would allow us to do is just comment out this line and make sure that it works. So if I comment out my mock here and run my test, this should still work.
Okay, so it makes sense that we would test it once, like with the real API, you'd have that so you can test it with the API. And then
exactly.
So that you didn't do it later. Okay, that makes sense.
Exactly. And when you get into mod 3, we'll actually show you a gem to do exactly that. It's called VCR. And VCR, if you know what a VCR is, if you can remember, VCR will record and play back cassettes. So in that gem, they actually use that language of the first time you hit the API, it'll record it. And then all future times you have that cassette stored for later use. So there's a gem that does exactly what you're describing.
Okay, cool. That makes a lot more sense.
Yeah, a better way to mock this, and I kind of went with this version just because it was like as quick as I could do it. I was kind of running out of time last time, but I think the better way to do this would be to actually mock out Faraday. I want to see if I can try that actually. Allow Faraday to receive get and return. Actually, let me actually see if I could do it like this. Let me just pry in and see what that response looks like. Oh, it's because I'm mocking it still. I ran into that last time. Undefined method pry for binding. I must not have pry installed. Come on. So if I look at my response, it looks like this is an instance of Faraday response. So I think a better test would be allow any instance, allow, and I want to change this to allow any instance of Faraday response to receive body, because that's the method that we're calling this, and return mock response. That makes more sense to me. And then no implicit conversion of hash into string line 5. This is rough. This is where this really starts to get rough, because this needs to be like exact JSON format. I'm going to see if I can do this. Add a colon here. This needs to be valid JSON. Take out this, and then wrap all of this into one giant string. Including the hash. Oh man, if this works. JSON parser error, yeah. So this is where this really starts to get rough, because if I'm mocking out Faraday, I really need this to be valid JSON. And for whatever reason, this just like isn't quite valid. It might be like the new lines here, but I'm not entirely sure. But this would be a better way to test this. Mock out, when you're thinking about mocking and stubbing, you want to mock the thing that you are dependent on. So in this case, we're dependent on the API. So that's the part that we would want to mock out. Again, like testing can get very complicated, and that's going to be like a bigger topic of mod 3. For now, I just want to see like some sort of testing. Can you touch on what an asset pipeline is? Maybe if I have time. I've heard of APIs being referred to as contracts. Can you explain this? Yeah, this is a really interesting way to think about an API. So the API contract is essentially, if I'm trying to use the API, so so a contract is an agreement between two parties. The two parties in the API is the client who is using the API and the server who is the actual API. So the two parties are the person trying to use the API and the API itself. From the perspective of someone using an API, it is a contract because you are expecting if you do a certain thing, you're going to get a certain thing back. So the API contract would be if I send a GET request to api.github.com/users and put in a valid username, then I would get back in my response body a JSON hash of all of that user's data. Just to really illustrate that, if we look at, let's look at reference here. I think this will probably be a better visual. This is a better visual of what the API contract is. So if you send a get to /user, your response should look something like this. Let's find another example here, maybe one that's not, is there a post in here maybe? Yeah, here's another example. If you send a post to /user emails with these parameters of accept and emails, then you would get back this response. Yeah. Does anyone have any other like clarifying questions around this idea of like API as a contract? I think that's a really good way to think about this. Can you put this API repo on GitHub for us? Absolutely. Do I have a, let's just add all. So not best GitHub practices here, but I think that's okay. And I think I actually made, yeah, I made one here for y'all. Oh, it's called master. And oh, this is the wrong one. I'm just going to delete this. Delete. Let's just remake it. There we go. Let's change this to main. And now let's push it. There we go. And I'll just drop this right into your cohort channel, so you have access to it. Okay, so that was this question. Yeah, I think we talked about this. We talked about this. So do we actually need to test that the API is returning what we want? If so, how do we do that without constantly calling the API? I think we talked about that in terms of the testing. When implementing an API, what would an example be of making a class to categorize the code for it? For example, an API connection class, API data class. I think we talked about that as well. Typically, you're going to have at least 2 classes when you are when you're dealing with APIs, and I would highly encourage you all to make as many classes as you can think of. I think I have rarely seen students over abstract their code. So if you're kind of wondering, like, should I make another class to make this a little more readable, a little bit more abstract, I would say just go for it. And if you go past the point and things get too abstract, you can always reel it back in a little bit. But typically, you're going to have at least a service whose job is to interact with the API, and you're going to have some sort of other class to process that data. In this case, that was my GitHub user class. Yeah, so I think the answer here would be like a model-like object, a Poro object. I say it's model-like because it kind of like models data, but it's not data in the database, it's modeling data from an API. Can you touch on what an asset pipeline is? This is a tough one here. I don't know a ton about the asset pipeline in Rails. What an asset pipeline is it is a or in Rails, what the asset pipeline is it is a mechanism for compiling all of your assets. And I'll touch on what an asset is in a second. It's a mechanism for compiling all the assets into one deliverable, into a single deliverable. So an asset in terms of our web applications and Rails specifically is anything under this app assets folder, which you can see includes your images, any JavaScript files you have, any style sheets. Yeah. The reason why this gets complicated is because the reason why the asset pipeline is a thing, the reason why we need like a whole delivery mechanism for all this like JavaScript and image stuff, the whole reason we need it is that web browsers will cache these assets. So caching is where you store something away for later use. So for example, a web browser might cache your style sheets. So as you're styling an application, a web browser might say, oh, there's this style sheet here, which tells me how I need to display it. Rather than asking for that every time, I'm just going to save it and reuse it. The problem with that is if you make changes and the browser is storing it, then you need some way to tell the browser, hey, this has actually been updated. So the asset pipeline will actually store your assets as the file name plus some sort of like unique identifier at the end. So that's like a very brief overview of how the asset pipeline works. It's a mechanism for like managing all of these assets. I don't want you all to dig too deep into this at this point, especially if there's other like content that we've had classes on that you could improve on. So the asset pipeline is something every Rails developer needs to like touch at some point. I would say like only touch on it once you really need to. If we kind of had a class on it right now, it would just be like not relevant at this point. I think maybe something more useful would be to just reference you to the Rails guides here, because this is kind of how I would be starting. I would be looking at what is the asset pipeline? Yeah, a framework to concatenate or minify or compress JavaScript and CSS assets. Yeah. So that's what I would point you to. And we just have some blank boards here. Cool, so I think I got through all of these questions here. I think I'll leave this Zoom room open for maybe another 5 minutes here. And if you all have questions, I'll stay on and answer them. Otherwise, we'll just kind of let it expire after 5. Does anyone have any questions? Jameson?
Yeah, since you're here, I was looking a little bit at the GitHub API. So when you just connect to a repo, the keys that get returned are just a lot of URLs. And those URLs, they have in curly brackets at the end of them. It's kind of looks like a dynamic value of some sort, whether it's like an ID. And I was wondering, yep. Is there a way that you can like dynamically put those in there, or would you be making a method that would just be looking at like filling in that value from scratch?
I don't think there's anything in terms of the GitHub API that would fill that in for you. I think you said it right at the end there. You would have to write some more code to dynamically fill in this value.
Yeah, and I guess just to like flesh out my thought is, if that is the return for the body, and I wanted to take that resulting URL and then make another connection with it, I couldn't really do that dynamically. That's what it sounds like.
You could. You could, it's just you would have to make some determination on what exactly you wanted it to do. So for instance, we could say, what route am I looking here? So I could say, it looks like this will give me a list of all of the repos. Is there maybe a simpler one? No, let's actually stick with this one. So I could hit this route here to say maybe I hard code in here the organization. So we could do like Turing School. This would give me all of my repos. So I could iterate over all those repos. And then for each of those repos, I could get the following URL out of that hash. And then what would actually use this URL for? Yeah, as I try to think through the example, I don't know how it actually use that URL. Do you have a use case, Jameson?
Yeah, I think I was looking at, if you go to the repo, so if you connect to a repository as opposed to a user, there's a key called collaborators URL. And I was just kind of like looking around with that.
So this endpoint is.
But I think you're right, because like the return string is like, it's not, it doesn't look like it's flexible because it just appends that like curly bracket at the end.
Doesn't look like it's. Can you say that one more time?
Yeah, and I can show you too. Maybe it might be easier that way. Yeah, so I was testing. So like parent, I think would be that hash. Oh wait, I guess it's not. Oh yeah, I couldn't connect. But the key in this case for like parent would be like collaborators URL, which would be that URL string. And then I was thinking, all right, what would it look like if I tried to do this?
Yeah.
But I don't know if you could do that because this string is like just a string, you know what I mean? With that little curly bracket at the end.
Right. Oh, because it has those curly brackets on it. Yeah, so what you might have to do is do some string manipulation to take off the curly bracket part of it. Yeah, again, this kind of just depends on like, I think where I'm getting lost is I don't really know what the like curly bracket syntax is for. Like, why would I need to specify? Can I take over the share?
Oh yeah.
So my question is, when I look at this collaborators URL, why would I need to specify a collaborator? Like if I know which collaborator I'm specifying. Oh, okay. So maybe something that this URL has here is, yeah, can I see this this endpoint on this page here? Is there org, whoops, what am I looking at? I'm looking at, no, I don't want users. I went back accidentally. I want repositories. And is there owner orgs? Is there collaborators? Oh, there's a lot. Collaborators URL. Branches. Oh, here we go, collaborators. So what I'm trying to do here, Jameson, is I'm trying to figure out why would you even put in that dynamic value. So I'm trying to read the documentation to see if it makes sense. Check if a repository is, yeah, okay. So this is why the use case was important, because I didn't necessarily get that from the URL, that this is checking if a repository, if a user is a repository collaborator. Yeah, and it looks like this doesn't even return to us a body. It just returns to us 204 if someone is a collaborator and 404 if they're not a collaborator.
Interesting.
Yeah, so I think the answer to your question, or maybe the context that we need to answer your question, is what are we using that URL for? If it's like a dynamic route that you really want to use, I would say like figure out the use case first. But you're on the right track when you showed me like you want to do GitHub service.connect. That is what you would want to do. You would want to take that URL and pass it back to your GitHub service to hit another endpoint.
Yeah, thank you.
You're welcome. Other questions? Natia.
Sorry. Clarification on the project. You have with the API the number of commits and number of pull requests for the users. Is that for the repo or just like total?
Let me pull up the let me pull up the project. And which one was this?
It is like the very end, the commits and PRs.
So I see the number of merge PRs across all team members. I see the number of commits. So I think this is the number of commits each person has made on the project.
On the project.
Yeah.
Okay.
Yeah.
That's cool.
All right, y'all. I think we're going to wrap it up here. Thank you all very much for your time, and I'll post this recording, and I've also dropped the repo with all the code in it into the cohort channel as well, so you can have that. Have a good evening, everybody. We'll see you tomorrow.
Thank you, Brian.